Hey everyone, so welcome to the third lecture of the Linux SysAdmin Decal. My name is Richard and I'll be your lecturer for today. And today's topic is shell scripting. So quick reminder right before we start is course resources. You have your facilitators. We're always here to help, so please ask us any questions if you have any. All the material new and old is online, and feel free to join in the in-person lecture time at 8 p.m. PST in the link provided. And yeah, email us and drop by in the Slack if you have anything to talk about. Also engaging with this lecture, just because it's remote, you can follow along at ocf.io/decal/slides/b3. If you don't have a terminal, you can always connect through the OCF servers. And if you have any questions again, please ask. Topics for today, we have bash, variables, conditionals, loops, functions, and streams. And then afterwards, I'll be showing some of my favorite examples of bash scripting and how they've helped me, and some pretty awesome examples. So what are we learning bash scripting? That's a good question. Let's pretend for a hot moment that you're a sysadmin. And as a sysadmin, you type a lot of commands, right? You do a lot of things, and you're a little lazy, you know? You don't want to like type the same command over and over again. You want to stay dry, you know? So that's why bash scripting allows you to basically tell the computer to do it for you. So you basically use bash scripting to tell the computer a set of instructions step by step, and then let the computer do the dirty work for you. This is the relevant XKCD comic. And so optimally, we would basically have the computer do some of the automation for us, and that should basically help increase our free time. At least that's what we hope to do. So let's start with bash. So most of you have probably used bash as a shell, but did you know it's also a programming language? And to get started with that really quickly, let's go through the basics. So how to write a comment in bash. Comments in bash are basically just pounds or sharps or hashtags, whatever you want to call it. And on the right, you can see an example. And shebangs. So shebangs are special comments that appear at the beginning of a shell script, and they come in with a bang and an exclamation mark, and then the path to the interpreter. And this basically tells the program what to use to execute the lines below. And so for the most part in our case, we'll be using /bin/bash. And also to run your script, don't forget to make an executable by doing chmod +x, the name of your script. And to actually run your script, you just do ./ and then your script name. Cool, and then we can do a quick hello world demo just to make sure everything is set up. Go to the right folder. Cool, and I'll be using Vim as my text editor. Feel free to use VS Code, Emacs, Nano, whatever you want. So don't forget to do the shebang. I'm gonna write quick hello world. Just do echo hello world, and that should be, let's call this hello world.sh, and that should be your first script. And you can see it right there, hello world.sh. So just don't forget to make an executable, and now you can actually run it. Hello world, congratulations, you have written your first shell script. And yeah, let's get on to basics with variables. So variables are pretty simple. They kind of like the same. You just have the variable name on the left side, equal sign, and then the value of the variable on the right side. And in this case, in bash, white space actually matters. So please don't put spaces in between the equal sign unless you know what you're doing. And to actually use the variables, you just do $sign and then the variable name. So going back to the example, we can basically do, say name is equal to Richard, echo the name. And so if we execute this, it should just say my name, and it does. So sweet. And if you want to do addition, you got to be kind of careful because bash variables are untyped. So in this case, foo equals 1, foo plus 1. What do you think this will do? This actually errors. And the reason is because operations are contextual. So if you actually want to do math like this, you'll have to use the expression command to actually evaluate expressions. So in this case, this instead of that is a valid command. Just remember to use that. So yeah. And if you want to read in user input, you can also do that with the read command. So you basically do read, and then the variable you want to write into from the input. And the -p is just an optional prompt to prompt the user. So for example, if we don't want to hard code my name, you can say read p, enter your name. And then we want to read this into the name variable. So So it'll say enter your name, you type in Richard, and it'll output Richard. Sweet. All right, let's learn about subshells. So subshells are basically help you do command substitution, which basically replaces the actual text of the command with the command's output. So in this case, I can just do like name is equal to the subshell ls-la, which basically lists all the contents in the current directory, and then I'll just echo out the contents of the current directory. And if this works, and it does, oh, my face is blocking a little. Let's do that again. If it works, you'll see all the files inside the current directory. Cool. All right, conditionals. How do we test stuff? So to evaluate an expression, use the test command. And this is also synonymous with the brackets, which I will show later. But just keep in mind that the test command will output 0 if things are true and 1 if things are false. And yes, that is correct. 0 is true and 1 is false in this case. Just keep that in mind. Yeah, and so there are a lot of comparators, and they're pretty straightforward if you know how to read them. You know, equals, not equals, greater than or equals to, less than or equals to. And there's a bunch of other stuff like is a directory, is a file or not, but I won't get into those. So yeah, let's look at this example quickly. What do you think this will output? And just as a reminder, the $? just echoes out the status of the previous command. And the answer is it will output 0 and 1, because the first one, 0 equals 0, so it outputs 0, which means true. And the second one, 0 is not equal to 1, so it outputs 1, which means false. And you can also write this in shorthand, like I said earlier, with brackets. So this is a lot shorter and somewhat neater. And following off with this, you can actually do if statements now. So you can do if the condition, then the actual thing you want to do. And remember to end it with fi, or the opposite of if. So in this case, let's do a quick one. Let's uncomment that. So you can say if name is equal to, Richard, then echo, hey there, buddy. All right, let's try that. So this should echo, hey there, buddy. And if I change my name to something like Kevin, nothing should happen because we're not inside the if statement. Yeah, you can also do else statements. So if, else, and you can also do things like elifs, which are basically just else ifs. It's kind of like Python. So if, elif, else, and just make sure you put the then keyword after the if statements. Cool. And if you're getting really long, there's also things called case statements that you've probably used before in other languages. It's just a little wonkier in Bash. So you can see here that the parentheses actually end the conditions, and the semicolons are actually the end statements. But yeah, I won't be getting into those too much, but do remember to end the case statements with esac, because that is the opposite of case. All right, let's move on to loops. So we all know about for loops, right? And it's a little like Python, where you can do like for variable in the iterable and then do echo or do whatever you want. And I can do a quick demo of this. Comment this out. So like, let's say you have a list that equals A, B, C, D. You do for item in list. Make sure you do and wrap it with done. Echo I. And this will just output A, B, C, D in the line. And you always do whatever operations you want. So you're like, hello there. Let's pretend this is a list of names. Hello there. And we'll just do hello there, A, B, C, D. Yeah, that's for loops. And where this could actually be very useful is if you're, say, mass renaming it. So for example, I'll make a quick files directory. So what I'm doing here is all I did was make 10 files named 1 through 10. And using this script, I will rename them all to new-1, new-2, new-3, and whatnot. So let's first cd into the files directory I just created for I in, remember the subshell command, that's where we're using it. So this just outputs the files in the directory. I'll show you quickly like that, cool. And let's call this F for clarification. So we're gonna echo renaming F to new-F. just do the move command here, move to new dash F. And if we run this, and hopefully it does work, my bad. Oh, yeah, wrong directory. Sorry, gotta be in the right directory when you run the files. Yeah, you should rename them, and if you just ls the files directory, you can see all of them are now renamed to do. So that's pretty cool, right? Yeah, so for loops are pretty powerful and what you can do like that. And there's also while loops. So you do while, condition, it's kind of the same thing, you get the point. And let's go on. So functions. Functions, you can actually write functions in Bash, and they're pretty cool. The only thing to keep track of is that you don't actually put the arguments inside of the parentheses like most other programming languages, but instead you use positional arguments. So like $1, 2, 3, and so on. And I'll give like a quick demonstration. Function greet. This will just do echo, hello there. One. And you just call greet on the first function given to the script. So in this case, we do, or actually it might be more clear if I do this. So we do that, what do you think will happen? It should be pretty simple, it just greets me, right? Hello there, Richard, makes sense. Cool. And yeah, you can, oh yeah, you can do some pretty complicated stuff with it. For example, you can actually, function Fibonacci, right? Classic programming problem. So let's do if the first argument is less than or equal to a 1, I believe, then echo 1. Else, okay, this might get a little complicated, but please just follow along. So we want to do some addition with some subshell calls. So we want to call fib -1. So that's, yeah, that's that, -1 plus fib -2. And I think it should be good. Yeah, don't forget the if. Yeah, let's hook this. Oh yeah, don't forget to call it as well. Fib, let's get like fib 10. And it should output just like, I think 55. Yeah, there you go, that's Fibonacci. And yeah, syntax in Bash isn't exactly the prettiest, but it works. Yeah, okay, let's go on the streams. Just review quickly. So the caret symbol, the more than symbol, basically outputs the output of a command into a file. And so I can do this quickly for you. So like go hello to file, and then if I just cat out the file, you can see hello is in the file. And similarly, you use the opposite caret symbol or alligator symbol to basically take input from a file. And so I actually have, you can see here, I have Moby Dick in a text right here, and what we can do is sort all the lines in Moby Dick just by that. Boom. And yeah, it's a really long output, but they're all sorted. You can trust me on that. And yeah, and the most powerful one, and probably one of my favorites, is called pipe. It's where you take the output of the first command and you pipe it into the input of the second. And with this, you can do some pretty powerful stuff. There is a story about, I believe, two programmers, one named Newth and one named McIlroy, where they were tasked with writing a program to find the n most frequent words in an article. And so Newth basically wrote like this 10-page plus Perl script, and it was, it was really low-level implementation. There were like try data structures and stuff. And then I believe McIlroy basically just took this and wrote it in a few lines of simple Bash, and I can actually try that right now, if I remember how. So what we're going to do is basically we're going to take in the input, and we are going to split all the lines, as you can see on the right, all these lines into individual words. So you're going to take the complements of anything that is not a word and replace it with a new line. Oh, that is wrong. New line. And then we're also going to lowercase it, just for fairness sakes. And then we're going to sort it. And then once we sort it, we're going to do unique, which basically it replaces all the duplicates with only one, and the -c flag tells us how many duplicates there are. And I'm going to sort again in reverse, numerically. And then we're going to output the first argument amount of the ones that we want. And so with this, we have written, what is this, 5? I can't count today. 6 lines of stuff. So cat Moby Dick, I probably can't see, it's cat Moby Dick to hello world. And let's say we want like the first line, the most frequent word. And so in this case, it's just the. And if we want like 10, we pass it 10. You can see all 10 of the most recent words. So yeah, this is basically what the essence and probably the magic of the shell is that you can basically chain these different programs to work together to achieve whatever sort of goal that you have, instead of writing a really complex algorithm or program to do it. Yeah, that's how pipes are really powerful. Oh yeah, and just some additional notes. As you saw before, writing Fibonacci in Bash isn't exactly the best, which is why Python, you can actually write shell scripts in Python. As long as you change the interpreter to Python, you write in Python, because Python has some pretty cool stuff like argparse, fabric, salt, psutil, and you're able to basically do some pretty a lot of heavy lifting with that. Complex data structures, recursion, OOP, and I'd say honestly, use Bash when the functionality that you want is basically easily expressed as a composition of command line tools, kind of like the one over here, as you saw. And yeah, right before we end, I can actually show some things for some examples. I wrote a script called, let me see if I can find it quickly. Here we go. I wrote a script called Chive because back in 61C, I had a project where I was supposed to do, I believe it was performance programming of like neural nets, and we're supposed to benchmark it on the Hive machines, but with everyone in the class benchmarking. A lot of computers were used up in the Hive, so I wrote a script to basically get me the least used Hive, or the Hive machine with the least amount of users. And I think I can actually show this in action. Yeah. So for example, the -v just stands for verbose, -u stands for user, and so over here you can see that I have logged into Hive 22, and we can see how many users are in each one. So the script basically just compiled all this and logged me into the one with the least amount of users. And oh wow, that's a lot of users in Hive 1. But yeah, so shell scripting is pretty useful. I also use it personally for everyday tasks, such as some of my scripts. I have like some backup scripts because I'm lazy. I don't like writing this really long command with lots of flags. And I also have some stuff for like backing up to encrypted disks and stuff like that. But yeah, also pruning, But yeah, shell scripting, really powerful, helps you do lots of stuff and helps you stay dry. And these are some other resources you can take a look at. There's the Nathan McElroy word count thing I talked about. There's the Bash guide for beginners from the Linux documentation project. And there's a really interesting video on the Unix operating system if you want to watch about it. But yeah, Google's your best friend. Good luck out there, and thanks for watching.